So this is original circuit. So we got 6.958 millivolts, and here also 6.958 millivolts. Same circuit I am using, but I am modifying it in the input side to calculate the input resistance. So I am going to add a variable resistor in series here. And make this to 0. Okay, and let me select default initial as interactive simulation. Previously we closed it at transient, so I am placing it interactive. Now let us run the circuit. 6.958 millivolts. Okay, now what we have to do is half of this value. So 7 millivolts if we assume, 3.5 millivolts is half of this value. So by varying the resistor value, the pot here, potentiometer, we must get here 3.5 millivolts. So let me set this value to some 5k. 5 kilo ohms means 0 ohms, so 6.958. Trying to increase this value and reduce the output voltage. I must get 3.5 millivolts. So until I get that value, I have to increase the input resistance. So 5k is not sufficient. So let me stop the simulation. So let us make it 10k. So 50% is nothing but 5k. We have stopped our experiment previously there. So if we run now also, we'll get that same 3.9. Now let us increase the resistance. So 60%. 6.5 kilo ohms is the input resistance here. So let us calculate now the output resistance. Here I have to place the resistor. And let us connect here across the output and ground. So let this value using larger resistances at output. Let us use 100 mega ohms and check the output here. Previous maximum is 6.957 millivolts. Must get 3.5 millivolts by varying this variable resistor. I am reducing its resistance. So nearly 20% of 100 ohms is 20 ohms. Okay, so this is nothing but the output impedance. So the CC amplifier is having very low output impedance, so that it can be used for matching the other networks.